Welcome to an instructional video for the Real-Time Water Systems Lab OpenStorm wireless sensor nodes. The OpenStorm sensor node operates on solar power, allowing for prolonged usage in the field. In this step, we will show you how to mount a solar panel to the sensor node. To begin creating the solar panel mount, grab an 18-inch by 5-inch piece of sheet metal. If you plan on making multiple nodes, we suggest creating a template so that you can quicken the rate at which you mark your sheet metal, such as the one we use here. Begin marking 9 dots on the metal for where you will need to drill later. The first 2 holes should be located at a 1/2 inch from the bottom and 1 inch from either side. The next 2 holes are 1.5 inches from the bottom and 9/16 from each edge, so that they are 3 7/8 inches apart. The next 2 are 9 3/16 inches from the bottom and 9/16 from the edge. Another hole is placed in between these 2 holes at 9 3/16 inches from the bottom and 2.5 inches from the side. Finally, the last 2 holes are placed at 14 5/8 inches from the bottom and 1 inch from either side. Next, you will need to mark the lines where we will bend the metal. The first line should be 1 inch from the bottom. The second line should be located at 9 10/16 inches from the bottom. And finally, the last line should be at 15 1/8 inches from the bottom. Try to keep these lines as straight as possible, as it will be very helpful later on. Next, we're going to begin the process of actually drilling the metal. To do this, you're going to want to first create indents on the markings in your sheet metal. Do this by grabbing a screw and a hammer and gently tapping the screw with the hammer on the marks. This will create an indent, which will help the drill bit line up more easily. When drilling the holes in the metal, use a 3/16 inch bit. To create the hole in the middle, you are going to want to use a 1 1/16 hole saw arbor. Next, grab a pair of tin snips and cut along the line that is closest to the largest hole. After you've cut the metal, it's a good idea to take a hammer and pound out any deformations that have occurred. Next, we're going to want to bend the sheet metal. This sheet metal, which will be used as our mounting brace, should be aligned with the bending brace. With the marked side up of the mounting plate facing up, align the upper fold line with the edge of the bending brace. Then bend the plate upwards along the upper fold line. The mounting plate should then look something like this. You should then repeat this process with the bottom fold line. Once you have bent your sheet metal as far as it will go in the bending brace, take another sheet of metal and bend it further, just like this. The mounting plate should now resemble this. Next, we're going to fasten the solar panel to the mounting plate using the 4 central screw holes we drilled and 4 440 thread-sized toothed hex nuts. Be sure that the solar panel's power cable is brought through the central 1 1/16 inch hole. To ensure that the hex nuts were tight, we begin to use a socket wrench on them. The final mounting plate should look something like this. Next, we will drill holes for 3 PG7 cable glands. This will allow us to accommodate the solar panel power cable, as well as cables for 2 sensors. This particular node will be equipped with a soil moisture sensor and an optical rain sensor. Begin by marking the holes. The first hole is 2.5 inches up and 1/2 inch from the left. Ensure that the hinge is on the left-hand side of your enclosure when marking the holes. 2 more marks should be placed a 1/2 inch from the bottom and a 1/2 inch from either edge of the enclosure. Next, take a box cutter or some sharp object and create indents for where your drill bit will go. When drilling your enclosure, start by making a pilot hole with a very small drill bit. Next, you're going to want to switch to the 1/2 inch drill bit. Slowly make your way through the plastic until it breaks through on the other side. Careful not to crack the plastic. If you plan on using an ultrasonic sensor, the hole you will want to create for the ultrasonic sensor should be created with a 1 1/16 hole saw arbor. Next, we're going to mark the drill holes on top of the enclosure. The first hole is located at 1 1/8 inch from the left and 1/4 inch up. The second hole is located at 4 1/8 inch from the left and 1/4 up. Use a caliper to get the best accuracy. Once you've done this to both sides of the enclosure, take a box cutter and again make indents on your marks. When actually drilling the holes on the rim of the enclosure, use a 1/8 inch drill bit. Next, open the lid of the enclosure and place 4 440 thread size screws in the rim using the screw holes drilled beforehand. The head of the screw should be on the inside of the lid. Next, fasten the screws on the upper rim to the screw holes on the upper face of the solar panel mount using hex nuts. The hex nuts should be located outside of the lid. Finally, fasten the screws on the bottom side of the rim to the lower face of the solar panel mount using hex nuts. Next, take heat shrink tubing and place it around the cable on the solar panel. Then, attach a gland and fit the cable and tubing through the gland. You will need to attach additional glands for additional sensors you wish to attach. You'll also want to attach Velcro to the insides of the enclosure. Once it's through the gland, take a heat gun and heat the tubing so that it shrinks. Finally, attach a terminal to the other end of the cable. Next, you're going to attach Velcro to the solar charger, the battery, and the antenna. Once this is done, you can attach the Velcro and place the items aside. To prepare the solar charge controller, all you need to do is connect the battery using the terminal on the board. The other load terminal should connect to the breakout board, using the red wire on the plus, or power, and the black wire on the ground, or negative. Connect the PCB antenna to the connector on the bottom side of the Telit cellular module. Then attach the Telit cellular module to its corresponding connector on the breakout board. Screw the breakout board to the 4 holes located on the bottom of the inside of the enclosure using 4 8/32 by 3/8 inch Phillips head machine screws. Now place all the components within the enclosure. Now that the enclosure is finished, you can begin to attach sensors. Next, we're going to prepare a Maxbotix depth sensor. Connect your Maxbotix analog signal cable, the white one, to the pin on the breakout board labeled P12.3. Next, connect the Maxbotix power cable, red, to the pin labeled VDD3P12.4. Finally, connect the Maxbotix ground cable, the black one, to a pin labeled ground. When the enclosure is finished, it should look something like this.